All right, this is lab demonstration for EC3301. This is lab number 6, the barrel and rotate shifter. And here we have the first 8 switches. These are the input. And then we have, for the 8th switch, we have a select. Um, and we are also representing the input here on the first 4 displays. And then here we're gonna see the output. We decided to show the input as well, just for convenience. So as we can see, we can set the input here. And then in order to set the second set of 8 bits of the 16-bit input, we have to push the select button, and then we can change it to however we want. And the next 4 switches are for the amount of steps that we either want to rotate or shift. So if we want to do it once, we can have that. If we want to do it 3 times, we can do it that way, and so on. And this last switch is for automatic, which we're gonna show shortly. The next switch after the amount of steps that we either shift or rotate is actually whether we do it to the right or to the left. So here, when it's high, we're gonna do the operations to the left, as we can see. And this other switch, what it does is that it decides whether we're doing shifting or rotation. Since we have it low right now, it's actually doing rotation. But now if we flip it, um, we shall see that it's gonna do shifting actually, as we can see. And now moving on to the last switch, the automatic, what we decided to do was to activate each step of the shift or rotation by a push button. So right now, if we push it, we don't see any changes. But once we set the switch to high, you can press it and see multiple changes. So right now I'm going to change it. Right now it's in shifting mode, so I'm gonna change it back to rotation, and we shall see all the stages. And every time we reach a 16, uh, the button is gonna reset because it acts as a counter in a way. And again, we can do it uh, shifting, we can do rotation, and we can do it either left or right to however we want. So here I changed left and so on. And that is, and of course, if we want to change the inputs, we can do it all the time. We can again set the first 8 bits by uh, doing setting the select to low. Then we can do that again. And yeah, this is the demonstration for this project. And now we will go into detail about how we wrote the code.
Oh shoot, how do I go back?
There we go.
All right. This is the presentation we have, our slides for Lab 6, barrel shifter / rotator. Here we have our schematic. We can see all of our modules here. We have our input select module with 8 switches for the input, and we have a 1-bit select switch that decides which input we will be putting in. This input select outputs to the shift rotator with a 10-bit output. And here are the 4 inputs for the 5 inputs for the shift rotator to determine if we will be rotating to the left the right or shifting to the right or the left, or to see if we'll be doing automatically or manually. We can see we have the increment module down here, which is for our automatic portion of the circuit. Every single time we press the button, the counter is incremented by 1, which is how we shift the bits over 1 each button press. The shift rotate has a 16-bit output that goes to the value digit module, which helps us select what we'll be outputting to the 7-segment displays. And we have a clock to determine which anodes will be turned on to see which 7-segment displays will be displaying which numbers at which time. This is the first module, our input select module. We have our input switch, which is our 8 switches to input the number we want to put in. And then we have our 1-bit select switch, which selects whether we'll be inputting, which selects which input we'll be putting in. And then we have our output here, 15-bit output, which goes into the the shift rotator. We use a always block that says when the select is high, the output is set to the higher 7 bits of the switch or the switches. And when it is low, the output is set to the lower 7 bits of the 8 bits of the switches. This is our increment module. When the button is triggered, we add 1 to the counter, which will be used in the shift rotate module for automated purposes. So here we have the clock connected to it, along with the button and the counter. The button is pressed once to increment the counter once each button press. And once the counter hits 15, the counter will reset back to 0. And now we have the next slide.
Okay, so in this module is where all the operations occur. We take the 16-bit input from the input select module, and then we also take all the inputs from the switches. And what happens here is that we make an always block that takes in all the sensible inputs, and from there we create different if statements for the possible operations that the user might want. So if we want to do shift to the right or shift to the left automatically or manually, we have an if statement for each of those cases. And now, in order to avoid issues with how scalable the code was, because we could have done multiplexers to create the logic for this project. However, it wasn't really optimal for this purpose, because if we wanted to have to create this project that way, it would have been a long mess of code. And so what we decided to do was to use conditional statements. What we found was that we could rotate an input based on stages from the amount of steps we wanted to rotate in this case. And so as we can see in the first if statement, we check for whether the bit of the amount is either 1 or 0. If it's 0, we don't shift. And if it's 1, we shift respectively 1 bit in the list significant bit. And then otherwise we assign it to as 1, which we're going to use again to test for the next bit of the amount of rotations. And if it's high, we're going to shift 2 bits, and again, we're gonna pass the same value. If it's 0, we won't shift, and then we're gonna do it again for a shift of 4 bits, and once again for a shift of, rotation for 8-bit. And this can be parameterized. If we set a parameter and set inside the brackets parameter -1, this can be much more efficient than actually using multiplexers. And now, when we want to do the rotations automatically, what we use is, of course, the counter, the output counter that we saw previously from Matthew. And to do the rotation to the left, we're gonna manipulate the same principle. We're gonna change where we shift, but the principle remains the same. And can you go to the next slide, please? Thank you. And as for the shift operations, we use the operators from Verilog. And of course, the amount would be taken in, and that would decide how many shifts we actually do. In case we want to do it automatically, we would take the counter instead. Next one. Now, the output from this module, as we know, is 16 bits. And since we are also displaying the input here, we had to break both the input and output into each 4 sets of 4 bits respectively. And since we're using a refresh clock of 4 bits, this is going to count up to 15, from 0 to 15. And we're going to actually display both input and output twice. And following that, we're going to use the same modules that we had on previous labs for the anode and cathode to represent each hex respectively. And yeah, this is the end of the presentation.